Hey everybody, so today we are talking about the angles of depression. Yesterday we talked about the angles of elevation, so we're just going to look at the opposite side of that, so the angle of depression. We are told that an angle of depression is going to be the angle formed by a horizontal line and the observer's line of sight as it goes down to an object below that horizontal line. Okay, so the angle of depression decreases below your horizontal line. Thinking back to yesterday, though, I wanted to bring up one really important point. The angle of elevation and the angle of depression are congruent. Okay, angle of depression are congruent. And so the reason I wanted to bring that up, if we're thinking about different situations, so we have these like horizontal lines in the sky and a horizontal line on the ground. And if you have, say, an airplane in the sky, okay, so we have this like airplane up here, and it's like flying in the air, okay, and if it was to look downward, okay, so as it moves from, say, flying in a straight line, decreasing, we create this angle of depression. But if there is a little kiddo standing on the ground and they look up at the airplane, we create elevation. Okay, elevation and depression. So the reason these two angles are congruent, if we think back to Unit 2, when you have two parallel lines that are cut by a transversal, the alternate interior angles, remember, are congruent. Okay, so if our horizontal lines are parallel, which they are, then this angle of depression and the angle of elevation created are in fact congruent. Okay, so these would be your alternate interior angles by the parallel lines. Okay, so just keeping that in mind. So our first problem, we have an emergency. So a search and rescue team is airlifting people from the scene of a boating accident. They observe another person in need of help. If the angle of depression to this other person, okay, so the angle of depression is 42 degrees and the helicopter is 18 feet off the ground or off the above the water, what is the horizontal distance from the rescuers to the person to this person to the nearest foot? Oh my goodness. Okay. So what we have to do, we have this angle of depression created by the angle from the horizontal line down to how far this person is. Okay, so it's 42 degrees. But remembering that elevation and depression are congruent, okay, notice we have these side lengths here. We create this right triangle. So here we will have an angle that is congruent to 42 degrees. Okay, so that angle is 42 degrees. Okay, so now I'm going to say, all right, I have this green 42 degree angle. What happens with my sides? I have a side opposite and the adjacent. Okay, so whenever I have opposite and adjacent, I'm going to think of SOHCAHTOA. Okay, opposite and adjacent fall under tangent. So we know that tangent of an angle is equal to the opposite over the adjacent. So I'm going to use this ratio to set up my equation. Tangent of theta, remember theta is my 42 degree angle, is going to equal the opposite, 18, over the adjacent, x. Okay, we're wanting to find x, or that distance from the rescuer to the person in trouble. So we need to get x by itself. We need to isolate it. But in order to isolate it, we need to get it away from the denominator first. So we multiply by x on both sides. Okay, that's going to leave us with x times the tangent of 42, equaling 18. And then last but not least, getting x by itself, we have to divide by tangent on both sides. Okay, this will leave us with x equaling a total of 18 tangent over tangent 42. All right, when you type this into the calculator, you will type it in exactly as it's written, 18 divided by tangent 42. That will give you about 19.99. But remember, we wanted our distance to the nearest foot, so X would be right around 20 feet. Okay. And then last example. Okay, so we're still doing the same thing that we did yesterday. Same concept, still working with trigonometric ratios. Here we have lifeguarding. So this lifeguard is watching a beach from a line of sight 6 feet above the ground. So the lifeguard is sitting on this tall tower chair, okay, 6 feet off the ground. She sees a swimmer at an angle of depression. So she looks down 8 degrees and sees a swimmer. Okay, how far away is the tower from the swimmer? Okay, so like in the last example, we have this right triangle that's created. Okay, we're going to say that our angle of depression is congruent to our angle of elevation. Right, so here we're going to have an 8-degree angle. Okay, we need to look at the measurements given. Okay, so 6 feet is opposite our 8-degree angle. So opposite. And then x is, again, adjacent. Opposite and adjacent is going to be tangent. Okay, so the tangent of theta is opposite over adjacent. We're going to plug in our values. 8 is our angle measurement. 6 over x. Okay, I need to solve for x. So I multiply both sides to get it out of the denominator. That leaves me with x times the tangent of 8 equal 6. Okay, and then to get x by itself, we divide by that tangent of 8. Okay, leaving us with x equaling 6 over the tangent of 8. So just like the last problem, you will type this into your calculator. Since we're looking for a missing side length, we use our regular ratio. And when you type that into your calculator, you will get that x, or 6 over tangent of 8, is about 42.69. Or if we round to the nearest foot, we will have 43 feet from the tower to the person in the water. Let me know if you have any questions. Good luck today.